So, hello. Good day, everyone. Thank you for being here. In this session, Sean and I are going to dive into some essential topics that form the foundation of effective oil analysis. Whether you're new to this practice or maybe you're looking to refine your skill, today's discussion will give you a practical knowledge and techniques to improve your oil sampling process and data accuracy. So my name is Nicole. I have been a client service associate here at Fluid Life for about a year and a half now, and I'm co-hosting this webinar with Sean, who has 7 years of experience here and is supporting me in my learning journey as I give my first Fluid Life webinar talk. This presentation will most likely take the majority of the time, so we will be following up with questions after the webinar. I encourage you to send us questions in the Q&A session throughout the presentation. If you're also interested in hearing the answer to a question, make a comment under that post and I'll make sure to include you in that answer as well. And with that, let's begin. So we'll start by looking at the objectives of lube oil sampling. Why do we do it? What insights do we hope to gain? And how does it support equipment health monitoring? Then we'll dive into the proper sampling methods, like what are the tools and techniques available for different systems, and how do we select the right method for each application? Finally, we'll break down the best sampling practices. What does good sampling look like, and how does consistency and cleanliness play a critical role in data quality? By the end of the session, you should have a clearer understanding of how to improve your oil sampling process to get the most reliable results possible. So why do we even test oil? Oil analysis is a simple and powerful way to monitor both lubricant condition and equipment health. Think of it like getting your blood drawn at the doctor's. By testing your blood, your doctor can look for early warning signs like diabetes, heart disease, mineral deficiencies, and even more severe cases like cancer. So you can wait until you start feeling those symptoms, which is a more reactive approach. It might cost you more in the end. Or you can get your blood drawn every year and monitor how your health is changing over time. This more proactive approach is similar to oil condition monitoring. By performing oil analysis on a regular basis, you will gain insights based on real-time data on the chemical health, contamination, and cleanliness of your oil. With this information, you can prevent failures, reduce downtime, and improve reliability for your equipment. Therefore, you must be able to trust your results. So all of that starts with proper sampling. A good sample can give you accurate data, where a poor one leads you to bad decisions. So you don't want to be this guy over here sweating, right? He's over here sweating, questioning whether or not if he should trust the results. Should he trust his results or trust that the sample was taken correctly in the first place? So good news, best practices are mostly common sense. Some of these things that we're going to discuss today will not be a surprise to you, like using clean tools, sampling under normal conditions, labeling your bottles, and being consistent. There are technical aspects too, like using dedicated ports, sampling frequency, and knowing how location affects what you're monitoring. But with the right setup and training, you will have confidence in results and a focus instead on how to resolve the maintenance issue. So now that we have a better understanding of why oil sampling is important, let's take a deeper dive into determining how many samples you need and where to take them. So what do you want to monitor? The number of samples you need and where you take them from depend on what you're trying to achieve in your oil analysis program. So first, start by identifying your primary goals. Are you monitoring filtration performance, diagnosing failures, identifying contamination aggression? Maybe you're optimizing oil change intervals. So each objective may require a different approach when it comes to the number and location of sampling points. So also ask yourself, what specifically do you want to monitor? Is it the overall system performance? Is it the condition of the filters? Is it pump wear or efficiency? Maybe it's the state of the bearings. So the more specific your focus, the more targeted your sampling strategy should be. A key point that often gets overlooked is consistency. So consistency is key. Once you determine your sampling location, stick with it. Drawing samples from different points on the same piece of equipment can give you very different results, even though it's technically the same system. For example, a sample taken upstream of a filter might show higher particle counts than the one taken downstream. So if you're not consistent, your data becomes unreliable and trending becomes meaningless. So define your goals, choose sampling points that reflect those goals, and then always sample from the same location. So what methods are available? So a common and widely used method is drain plug sampling, where you draw oil directly from the drain plug. You'll commonly find these on differentials, transmissions, wheel hubs, engines, and particularly on older models without built-in sampling ports. However, newer equipment often includes a pre-threaded port or plug location where sampling hardware can be installed. So while drain plug sampling is simple, it's not ideal for trending, as it can collect settled debris or be affected by dead zones in the sump, which these will skew your results. So if you decide to use this method, it is important to let the sample drain for a few seconds before collecting it. Another common method uses a vacuum pump or a suction pump to draw oil through an available opening, often by accessing like a fill port or through a dipstick. Some key points to consider when using this method is to be careful to not overfill that bottle. Overfilling may result in a contaminated pump. This will contaminate any following samples and then ultimately result in the failure of that pump. And that is because these seals in the pump are not compatible with that oil. Mini mesh valves are considered one of the best practices for clean, pressurized, and repeatable sampling. So these will make your oil sampling easier and more consistent. For newer equipment, some OEM manufacturers are now installing KST sample valves during the manufacturing process. So you might already have these on your equipment. If your system doesn't already have one, it may at least have the ports available to install these valves. Mini mesh valves allow for live, consistent, and clean sampling, and it's much easier to do. So that's what I call a win. No matter what method you choose, whether it's the drain plug, the suction pump, the mini mesh valves, your sampling method should reflect both the equipment type and your level of access. So the drain plug sampling might be the only option on some of these older systems, but wherever possible, incorporating these mini mesh valves will yield the most accurate and consistent results over time. All right, so common sampling locations. So when it comes to oil analysis, where you draw the sample from is just as important as how you draw it. And that is because the sampling location has a direct impact on the accuracy and reliability of your results. So listed here are some general rules or strategies that you can follow to ensure you're getting a representative sample. So first, at a minimum, always try to sample from the reservoir. This gives you a general view of the oil condition in the system. Second, whenever possible, sample before the filter. So this is important because the filter removes those wear particles and contaminants, which is what it's designed to do, but it's also the things you want to measure. So sampling before the filter gives you a truer picture of what's circulating in the system. And then third, you can sample after the pump. That's also ideal. And that ensures that there's pressure at the sampling point and can help you detect pump wear by picking up any metal particles generated from the pump itself. So now it's important to note that these are general guidelines. We'll get into some more specific things here in a little bit. So sampling locations can vary depend on the type of equipment and how accessible these points are. So in many real-world situations, you may encounter hard-to-reach areas, physical obstructions, maybe some safety protocols that prevent sampling while the equipment is running. In those cases, you might only be able to take a sample point when the system is shut down, which isn't ideal, but sometimes it's the only option. Others, units with dedicated sampling ports or installed hardware make it easier and safer to take consistent, high quality samples. So while these are good general rules to follow, it's just as important to understand your specific equipment layout and then work within those practical constraints. All right, so here is a table that provides general guidelines for sampling point locations specifically for mobile equipment. So in general, your good locations are going to be drain plugs. Your better locations are going to be your suction pumps, and then your best are going to be using sampling valves. Now, recall that you will have your own specific sampling goals. So also want to pick locations that align with those goals. So like, are you monitoring filter performance? Are you monitoring contamination regression, maybe oil change intervals? So make sure that you pick locations based off of that. Once you understand your sampling goals and your specific equipment, be consistent and sample from that same location. This will help provide reliable and trendable results. Another important aspect of getting consistent and reliable oil samples is having proper protocols, procedures, and training in place to support those sampling goals. But that's a whole other topic, and I'm going to let Drew handle that with his MLA training. So for now, let's take a deeper dive into sampling locations for engines, differentials, hydraulics, and coolants. All right, so there are a couple of options when taking a sample from an engine. If it's available, one of the best locations is to take a sample from the installed ports, so specifically after the pump, but before the filter. So this will provide results based on any metal wear generated from the engine and the pump before being filtered out. One common area where you can find that or add the installed port is going to be on the plug on the filter housing as shown in this photo. So sometimes these sample ports are hard to reach or might cause some safety concerns. So another option is to install a remote access kit. So this image on the bottom here is an example of what a remote access kit looks like, courtesy of JetFluid. These can be installed by make accessing these hard to reach ports a lot easier. And then sometimes it's the only way to access them. So if you decide to use a remote access kit, make sure you consider the likelihood of the kit of being broken or getting in the way when operating that equipment. Also, because this is a stagnant line, to get a representative sample, you will need to flush a lot more oil. So definitely keep those things in mind. Two other sampling locations for an engine is through the dipstick and through the drain plug. If you decide to use the dipstick method, you run the risk of contaminating the sample with sludge sticking along the dipstick tube. So to address this, cut a length of sample tube that's a bit longer than the length of the dipstick and run it down the tube. Withdraw it, see if it's dirty, and then repeat that until the tube comes back clean. So oily is okay, but you don't want any of that sticky sludge. So once your Subli tube only shows clean oil, then you can use that vacuum pump to draw up a representative sample. Lastly, if you decide to use the drain plug location, make sure you take a midstream sample. And this is because debris and water is going to settle to the bottom, which will skew your results. And so therefore, you want to make sure that you let some oil drain out for a few seconds before taking that sample to remove some of those particles. All right, so for differentials, the sampling locations are typically through the breather line, the top-up plug, or the drain. Since the oil is normally not changed on a differential when a sample is taken, a midstream drain tends to be impractical for most cases. So given the choice between sampling through the breather line or the top-up plug, I would recommend taking a sample from the top-up plug so it doesn't interfere with the integrity of your breather line. So there's technically another sampling technique that can be applied to differentials as well as other low pressure systems, and that's using a pitot tube. Now, this is more common when a differential has more than one top-up plug, since installing one of these will render that plug unavailable. However, if it's possible, pitot tubes do allow you to take samples from a consistent depth, and as we've discussed, consistency is key. So if you decide to go this route, you will want to make sure that the pitot tube does not get in the way of any moving gears. So, all right. Now let's talk about some hydraulics. All right, so I'm going to need to ask you to use some of your imagination on this slide. So here we have a basic 2D diagram of a hydraulic system. On the bottom here, we have the hydraulic reservoir where the oil then gets drawn up through the pump and into the supply line filter before finally being pushed into the cylinder. Now, this cylinder here, imagine this as an arm on an excavator or maybe the hoist or ram on a dump truck. So then the oil then will continue back through the return line filter before it gets pushed back into the reservoir to be recirculated again. So to monitor damage to one of the most critical parts of the system, which is your hydraulic cylinder, the best location will be on the return line before the filter. So not only that, but the return line does have lower pressure than the supply line, and so it makes this a safer location to pull a sample. So that is your best location if possible. If that's not, then another primary location is taking a sample downstream of the pump and before the supply line filter, so right around here. When you compare the results of this sample to, say, like a reservoir sample, you can monitor the wear generated from this pump. You will want to be more cautious when taking a sample anywhere before the cylinder, as this will be highly pressurized. So depending on your oil analysis goals, there are other locations as well that can be sampled from. So for example, if you want to measure how well a filter is working, you can sample before and after the filter and compare. If you just want to know a general overall health of the system, then you can take a midpoint sample from the reservoir. All right, so just like with oil samples, the best location for coolants will be on a sampling port that is found upstream of the filter. So here is a photo of a coolant sampling port, specifically on a Caterpillar, where this green cap here designates a coolant sampling location. So when taking a sample from a sampling port, set the engine to a low idle, remove that dust cap, and clean that sampling valve. So once you're ready to take that sample, slowly push on that push button or slowly insert the sampling probe, as that coolant will be hot and can spray out since it's under pressure. If this is not an option for you, the next best location is going to be through the radiator cap. So unlike many of the other locations that we have discussed so far, this one does require the engine to be shut down for approximately 1 to 2 hours. If the cap is still hot, do not remove that cap. Continue to let it cool. Otherwise, once it's cooled down and maybe it's just more on the warm side rather than hot, slowly open that cap. You want to take the same precautions as you do with the push button or the sampling valve, because it's going to be under pressure. So you want to be careful with that. Once it is safe to take that sample, thread the sample bottle and tubing onto that sample pump, insert the plastic tubing into the radiator tank, and then pull that plunger back to flush before collecting that. Sorry, my headset just turned off on me. So ideally, you're going to want to flush before you take that sample. And then when you're ready to actually take that sample, you're going to want to make sure you put the tubing in the middle of your coolant tank. As a last resort, you can take a sample from the overflow tank. However, this does not provide a representative sample of your coolant system. So, and that's because the overflow tank is the dumping ground for any coolant that gets spilled or splashed into this tank. So, if possible, take a sample from a dedicated sampling port or through the radiator cap instead. All right. So, now that we've discussed sampling locations for many components, another option is to add a sampling manifold where lines from multiple components are all found in one sampling location. So these work well with pressurized circulating systems like engines, hydraulics, transmissions. One of the perks with this is now you don't necessarily have to wait for a technician to come out and take that sample. You don't necessarily have to wait for a PM. You can just ask the operator to hop off and you can take that sample with little disruption. Not only that, but since these are attached to circulating lines, you do not have to flush nearly as much oil to get a representative sample. Woohoo! All right, so now that we've discussed locations, let's get into some sampling frequencies. So how often should you be taking samples? Well, in general, these are the recommended sampling frequencies. However, every company, every equipment might have its own unique circumstances that might alter these sampling frequencies. So, for example, criticality needs to be considered. If the failure of that piece of equipment will result in significant problems, you may wish to increase that frequency. On the other hand, if you had a lot of spare parts or that particular component is cheap and easy to replace, then those could be sampled less frequently. You should, however, also check with the OEM guidelines. Some OEMs do require more frequent sampling than others, and it would suck to lose a warranty claim over a $20 sample. So make sure you check those OEM guidelines. All right. So the last topic I want to discuss are best practices. And I wanted to end with this because this is what I call the low hanging fruit. Or, in other words, these are the small changes you can do today to make your oil analysis program better. Remember, you don't want to be this guy sweating it, questioning whether or not if you should trust the sample or trust his results. So, how do you take a sample that you can trust? First, if possible, take a sample while the system is live. This will ensure that the contaminants that have settled to the bottom, or maybe they pool to the top, are evenly mixed and will be captured in that sample. If it's unsafe to take a sample when the system is live, run the equipment for a while, make sure it's really warmed up, then shut it down, and then collect that sample while it's still hot. So it should be within 15 minutes after shutdown. Next, use a clean lint-free rag to wipe down that sampling port or drain plug. And you want to use lint-free because otherwise those fibers are going to get into your oil and then it's going to come in as a contaminant. So try to use that lint-free rag if possible. This helps to prevent any external contamination from entering that sample, as well as not contaminating the oil still left in the equipment. Third, you're going to want to use a sample bottle that is actually intended for oil sampling. Otherwise, you're going to introduce some cross-contamination. So even if these have been cleaned, they will still be water or soap left in the container. And then it's going to show up in your results. So make sure that you use sampling bottles that are actually meant for oil analysis. Once you're ready to take that sample, start by only removing the sample bottle cap. So that cap should stay clean. Don't put it in your pocket. I know it's tempting, but don't do that. Don't set it down where it might pick up some dirt, and then don't let that airborne dust and debris settle into that bottle. Also be mindful of where you place the sample bottle lid. So if you do, you always want to have it face up on a clean surface, and then avoid touching the inside of that bottle or that lid, because then, oils and whatnot and dirt, anything, we get down and dirty. So all of that's going to get into that sample. All right. So are we ready to take that sample yet? No, not quite. So before filling up that sample bottle, you want to send in for analysis, you need to purge or flush some of that oil every time. Cannot emphasize that enough. You want to purge that every time. The amount that needs to be flushed is going to depend on the location as well as the sampling method. So some of the factors that will increase that flush volume are going to be lengths of plastic tubing. So, might have some plastic tubing that's attached to the filter where you're going to be pulling it from. You need to consider the plastic tubing that's on your suction pump. So any of that plastic tubing, you need to include that length. You need to flush out that length as well. Dead legs. So remember those remote access kits that we're talking about that we can add to engines? Those are stagnant oil. So you want to make sure that you flush that out because that oil's just been sitting there and it is not representative of the oil that's actually circulating through your system. Another one that's kind of interesting is you actually want to flush out those sampling ports, valves, and probes as well. So you want to flush out any dust or dirt that ends up getting stuck on that sampling valve. So even though you might be wiping it down with a lint-free rag, there's still going to be some kind of hidden inside there. So make sure you flush even a little bit out, even if it's just pulling directly from that sampling port or valve. Once that oil is flowing clean, then you can take that sample. So as you're filling that bottle, try to avoid getting the oil on the threads. Oil on the threads can stop the lid from sealing properly, which might cause leaks during shipping. Also, do not reuse sampling tubes. So whenever you're taking a new sample, even if it's on the same system, you should use a new tube. So we discussed earlier how sampling locations can monitor different parts of the system, before or after the filter, right after the hydraulic, right after the pump. And depending on that location, we'll monitor different parts of your system. So for that same reason, you need to change out that sampling tube every time. Otherwise, you're not getting a representative sample. So instead, you're now getting a mixture of whatever was previously sampled with whatever is contaminated in that new sample. Additionally, make sure you label your bottles, either pre-label or do this immediately after sampling. Do not try to rely on your memory. Also, make sure to include all information that's required for identification. Here, this person did a great job labeling which sample belongs to which component, but unfortunately they did not fill out the label on the bag, nor did they register the samples. So when we received them, we had no idea which unit these samples belong to. And then finally, after that sample is taken, allow it to cool and then retighten that lid. Also make sure to place that sample inside that provided shipping bag. That outer bag protects that sample and helps prevent accidental leaks or loss during transport. All right, we're almost done. Woo. All right, so I want to end with a quick story. This is an actual report, by the way. You can see that there's a lot of wear, a lot of contaminations, even some degradation going on. In the comment section, there's strong words like severe, catastrophic, and immediate corrective action is needed. So does not look good, right? So after the PM received this, he pulled the unit from the field so he can do some maintenance work. Since the oil was contaminated, he did an oil change, scheduled some inspections, and even started ordering parts because he predicted that a failure is coming soon. Before he did a complete overhaul, he did have the technician take another sample to try and establish a failure trend. This time, when the results came back, the report came back clean. Wait, what? So now the PM is confused. So he goes back to the original technician that took the first sample to see if he can provide some more insights. And guess what? It turns out the technician forgot to take a sample before draining the original oil. So he scraped some oil from the bottom of that pan. So in conclusion, oil analysis is a simple and powerful way to monitor both lubricant condition and equipment health, as long as you use proper sampling techniques. The reason why oil sampling is critical is because it provides real-time data that planners, reliability engineers, fleet managers, and others can use to make decisions. They can schedule downtime, prevent failures, all those things. You'll want to match the sampling location, frequency, and methods with your specific oil analysis goals and within your specific working environment. And last but not least, be consistent. Your oil analysis program is only as good as your sampling techniques, and you must be able to trust your results. Thank you all for attending my first webinar. I hope you can at least take one item from this presentation and implement it with your oil analysis program. As a thank you, here is that promo code for anyone who has registered and attended today. This promo code will give you a $105 discount when you register for the MLA MLT training exam. Drew's going to be holding 2 training sessions this fall. One's going to be right here in Irving from October 21st through the 24th, and a second one in Edmonton on November 25th through the 28th. If you have any other questions, please send them our way in the Q&A, and Sean and I will be happy to follow up with you, or feel free to reach out to our customer care team at customercare@fluidlife.com. Thank you all, and have a happy Wednesday.